This is Unit 1, Lecture 2, Frequency Distribution. Wherever you look, whether it be newspapers, corporate reports, government reports, we are surrounded by tables and graphs and graphics. This is visual data, and it's important because it can convey information and concepts through graphs or graphic representations. Complex information can be summarized and made more readable. And it's easier to spot trends or see information sometimes when it's visually represented. Take, for example, we have this chart, and it shows the data stocks for the Dow Jones Industrial Average, which is rather complicated in and of itself. It shows revenue in billions and ranks, and then percentage on returns. And say you just wanted to find out those corporations that had profits between 50 and 100 million or 100 billion. It would be difficult to go through and find each one, or this isn't summarized in a way that's relevant to you. So we could make a frequency table. This is a fairly simplistic one. It only has 2 columns. It's got the annual revenue as bins, billions of dollars. First class is 0 to 50, basically, 0 to 49.9, because there can't be overlap. Second class is 50 to 99.9 billion, and so on. And then we have the number of corporations that actually have billions of dollars from 0 to 49.9 in revenue. Well, there's 13 of them. Then there's 10 that have revenue in the billions of dollars of 50 to 99.9 billion, and so on. So a relatively simplistic way to reduce that complex information into a more readable format for information that we are interested in. So we are only concerned with frequency tables in this course, and that's that visual representation that summarizes that data and information and makes it more readable or more relevant for what we're interested in. And that's done through the binning of the information, putting the information, the data, into classes. So frequency distributions can have various shapes and sizes and designs depending upon what information you're interested in. We are only interested in a frequency distribution table, which will have classes, and then the frequency, and then the relative frequency, and then the cumulative frequency. So let's look at classes first. And these are the bins or categories, and they have a range of values that are found in the data. The first thing you have to do is decide on the number of classes. So let's look at this example. We have gone to Quick Oil Change Company, and we've asked them the number of oil changes for the past 22 days. And here's the information that they give us. So one day was 65 oil changes, and then 98, and 55, and 62, and so on. So we want to sort the data into numerical order. That's the first thing we want to do. And that's fairly simple. We know our lowest number is 51, and then our next day of oil changes, that's 55, and then we have 2 days where there were 56 oil changes, so remember to include repetitions, and so on. So in ascending order, we have our oil changes that look like this. 22 days of oil changes that range. The lowest day had 51 oil changes, the highest day had 98. Now we want to be able to put them into classes. How many classes can we have? So we noticed that when we had the stock market example, we had classes from 0 to 49 and so on up. But how many of them did we have? Well, there's a formula, and that formula is 2 to the power of k is greater than n. So n is the total number of data in the sample set. So in this sample, we have 22 days that we sampled, so n is going to be 22. K will be the total number of classes that we are going to create, so we have to find out what does k equal. So we have 2 to the power of 2. We'll just do some guess and check. Well, that's only 4, and that's less than 22. 2 to the power of 3 is 8, still less than 22. 2 to the power of 4 is 16, still less than 22. But 2 to the power of 5 is 32, and that's greater than, obviously, 22. So we will need 5 classes. But how wide should each class be? Should it be 14 oil changes wide? Should it be 5 oil changes wide? Well, again, there's a formula for that, and that's the class width is equal to the maximum value minus the minimum value, so we already know that's 51 and 98, divided by the total number of observations, which is n. So the range, which is the maximum value minus the minimum value, divided by the square root of little n. So 98 minus 51 is 47. The square root of 22 is 4.69, and don't lose any of those decimals. So 47 divided by 4.69 is going to be 10.020. Well, you want each class to be a whole number, relatively speaking, so you want equal class widths and convenient class limits, so we'll make our class width 10 oil changes. So how's that going to look? Well, class 1 is going to be between 50 and 59 oil changes, because that's one below our lowest value, and then 10 oil changes up would be 59, and you don't want overlap, so class 2 is going to be 60 to 69, class 3 will be 70 to 79 changes, class 4 will be 80 to 89 changes, and class 5 will be 90 to 99 changes. And that will cover all of our data from 51 oil changes to 98 oil changes in 5 convenient classes of a width of 10. Next thing we need to do is frequency. Well, frequency is just the number of observations that fall into that bin or class. So here we have our information in ascending order, and we are going to find in class 1 we have 1, 2, 3, 4, 5. 5 observations. 5 days have oil changes between 50 and 59. For class 2, we have 1, 2, 3, 4, 5, 6. 6 days fall in between 60 and 69 oil changes. Class 3, we have the same. We have 6 oil changes that fall between, or 6 days that have oil changes that fall between 70 and 79. Class 4 is 2, and then class 5 is 3. Relative frequency. Relative frequency is just the proportion of the total observations in each class. What percentage of the observations fall in the class? It can be expressed as a percentage or as a decimal. And it's going to be the class frequency divided by the total number of observations. So in class 1 we had 5 observations, and we have 22 days in total. So 23% of oil changes fell between 50 and 59 over those 22 days. And mind you, if you look carefully, of course, 5 divided by 22 is not an even 23. You are going to have to round appropriately. For 6 over 22, it's 27% of the data. And again, for class 3, class 4 is 9%, and class 5 is 3 divided by 22, or 14%. Keep in mind that all of this will add up to 100%, so round accordingly. The cumulative frequency is just the running total of both the relative frequency and the proportion or percentage frequency. How is that done? Well, for class 1, we have a cumulative frequency of 5 observations and 23% of the data. From there, if we look at 5, we're going to add 6 more, and that's going to give us 11 pieces of data, and 23 plus 27 will give us 50% of the data. So in class 1 and class 2, there is 50% of the data. From class 2 to class 3, we add 6 more pieces of data and 27% of the observations. So class 1, 2, and 3 contain 17 observations and 70% of the data. Class 4, there's 2 more observations, so class 1, 2, 3, and 4 have 19 pieces of data and 86% of the observations. And finally, you should have 22 pieces of data after class 5, because there's only 5 classes, and 100% of the data. Then adding totals, we have 22 pieces of data. Your relative frequency should add up to 100%. What do we do with this? Well, you can look at these frequency tables and glean some information. What kind of questions might you be asked on an assessment after you've created your frequency table? The least amount of data falls between blank up to blank oil changes. So the least amount of data is going to be class 4. And how many oil changes are there? Well, between 80 and 89 oil changes, there's only 2. So we're going to have between 80 and 89 oil changes is where the least amount of data falls. The majority of data falls in class number blank and represents what percentage of the data? Well, we have 2 classes here, class 2 and class 3 both have 6 pieces of data, so it's going to be class 2 or 3, and both class has 20% of the data. Blank percentage of the data falls under 70 oil changes. Well, there's 70 oil changes, so it's going to be just class 2 and class 1, which means that 50% of the data falls below 70 oil changes a day. The sample size, as we know, are 22. This should be 22. And blank percentage of the data falls between 70 and 89 oil changes. So between 70 oil changes and 89 oil changes is class 3 and 4. So it's going to be 27 plus 9% of the data, which is going to be 36% of the data falls between 70 and 89 oil changes. 70% of the data is under how many oil changes? Well, we have 70% of the data in class 1, 2, and 3, and class 3 goes from 70 to 79, so 70% of the data falls under 80 oil changes. With frequency tables, we can create histograms, and histograms are a type of vertical bar chart. They are just a bar chart or bar graph. And remember that you have to have the horizontal axis labeled, and you label them with your classes. The vertical axis is labeled with the frequencies in that class, and then there's a bar for each class, and the height of each bar corresponds to the frequency of each class. So you must include a title with the histogram and make sure to label and scale the axis properly. So let's take our data and put it into a histogram. And here we have a title. Make sure you have a title, oil changes. We have properly labeled axes, the frequency on the vertical, and the number of oil changes in this example on the horizontal. And then each one from 50 to 59 this one has 5 observations in it. Remember, 60 to 69 oil changes had 6, as did class 3 from 70 to 79. And then class 4, which was 80 to 89 oil changes, 2 days had 80 to 89 oil changes. And then class 5, which was days that had oil changes between 90 and 99, only had 3 days. So the most important things to remember: your title, labeling your axes, and then you can draw. And that concludes Unit 1, Lecture 2. Please try the questions for frequency distributions so that you can get some practice and get an idea of what kind of questions will be expected of you.